Hello, students, and welcome to our lesson on literal equations today. Our do now, we will be asked to respond thoughtfully about a question that involves being proactive versus reacting. So you can be reactive or proactive, and we'll ask you to respond to that. Today, our objective is to solve literal equations, and we'll learn what those are. Our essential question: what is a literal equation, and how is solving a literal equation different from other equations we have solved in algebra? We will watch video and take careful notes. Literal equations stump some algebra students. It doesn't have to be that way as long as you remember to use your inverse operations with the letters, the variables, just as you would with numbers. And in fact, I would argue that literal equations actually should be easier because we don't have to do much adding, subtracting, multiplying, and dividing. Our exit ticket asks the question: what is the first question you should ask when solving a literal equation? And why is it that literal equations do not simplify nicely? We have homework 6 on literal equations, and I want you to go to that unit assessment and do problems 14 and 15. As always, we have important information. I want you to look for and take advantage of any extra help sessions that are offered in algebra. And make sure, this is your responsibility, that you've had a one-on-one appointment with me to show your work. Remember, we have those approximately every 2 weeks, and you can look at PowerSchool and see where you are with those appointments. And remember also, students, you have in posts in your Teams class a spreadsheet that shows you how to calculate your grade. So remember, we want to do all of our work when it's assigned because all of these concepts in algebra build on each other. So you don't want to get behind. So there's our Halloween pumpkin for today. And let's begin. Here is your do now question. At this point, we've probably talked about it in class, but take a moment and respond to this. Name a time when you reacted to a situation. Reacted, just kind of the first thing that came into your head, you reacted, you said it or did it. Think about how you could have been proactive, okay, thinking ahead of time, and produced a better result. And what was the difference with those two scenarios? That's really good thought for everybody, not just 8th grade students. And our exit ticket today, let's look at that ahead of time. What is the first question you should ask when solving a literal equation? And why is it that literal equations do not simplify nicely? So literal means letters. And literal equations are equations with multiple variables. So let's write that down now. Literal equations are equations multiple variables. The variables are the letters. Okay. You're going to have 2 or more letters in the equation. So just to warm us up a little bit, we are asked to solve each of the equations for x. So this first equation is not a literal equation, but the first thing we would do, we would isolate the term with 2x, and then we would isolate x. So to isolate the term, I'll need to add 5 to both sides, which leaves me with 2x equals 18. And then I need to isolate x, which I'll do with division, because x is being multiplied by 2. So I will do the opposite, which is divide by 2. And my final answer will be x equals 9. Now, if we were to solve this variable for x, okay, same thing. We have the term with x in it that we want to isolate or make by itself first. So what's happening to this term ax? Well, b is being subtracted from it. So I'll need to add b, and whatever I do to one side of an equation, I do to the other. Now, b and c are unlike terms. I cannot combine them. So what I have is, on the right side of the equation, c plus b. On the left side of the equation, I still have my positive ax. Now, just like I did over here with x, when I asked what is happening to x, I ask, what is happening to x? Well, x is being multiplied by a. So I will use inverse operations. I will divide by a. And now I've isolated x, and x equals c plus b divided by a. And that is a final answer. So the methodology is the same. So both equations, let's identify similarities and differences. So both equations use opposite operations to isolate. And I can also call that inverse operations. And another way that they're different, and if we look at our answer here, we have x equals 9. Here we have c plus b, the quantity of c plus b being divided by a. And that's a way that they're different in that literal equation does not simplify nicely because we cannot combine those multiple variables. So the literal equation does not simplify nicely. Due to multiple variables. So let's solve some examples ourselves. So the first thing we need to ask is, what am I solving for? So let's write that down. Ask, what am I solving for? I look at this first equation, it says to solve for w. So I need to solve for w. The second thing I ask is, what is happening to that variable? And here, if I look at w, and I say, what is happening to w? W is being multiplied by L, which leads me to my next step, which is to use inverse operations to undo and isolate. And that's how we solve. So what is happening to w? W is being multiplied by L. So the inverse operation of multiplication is division, and whatever I do to one side of an equation, I do to the other. So the L over L, basically equal 1. So we say cancel, but what we're really doing is we're making them equal 1. But on the left side, I still have A divided by L. And at this point, I want to remind you, students, to be very careful about uppercase and lowercase letters. If they've given you uppercase, it's uppercase. If they've given you lowercase, it's lowercase. So in this case, we have an uppercase A divided by a lowercase l equals W. That's what we needed to solve for, and our work is done. That's our final answer. Now, I can rewrite this. I like my variable on the left usually as W equals A over L, and that's okay too. They equal the same thing. Let's look at number 2. We're solving for H. What is happening to H? H is being multiplied by B. So I will divide by B. Whatever I do to one side of an equation, I do to the other. And that leaves me with an isolated H. H equals uppercase A over lowercase b. Here we're asked to solve for T. What's happening to T? It's being multiplied by R. So I will divide by R. Whatever I do to one side of an equation, I'll do to the other. T equals D divided by R. You see, we really don't even have to add and subtract and multiply and divide with some of these. We're just manipulating the letters to isolate a given variable that we're asked to solve for. Number 4, we're being asked to solve for T. T is being multiplied by PR. So we will divide PR out of there. Whatever we do to one side, we do to the other. So PR cancels on the right because PR over PR equals 1. I've got my T isolated, so I'm done. T equals I divided by PR. Similar to number 4 is number 5, where we're being asked to solve for H. H is being multiplied by LW. So I will use the inverse operation of addition to divide by LW. Now I've got my H isolated at this point because LW divided by LW equals 1. So now I am finished. I have my H equals V over LW. Okay, don't get scared by the exponent. We're being asked to solve for R, and I'm about to show you something that might be the first time you've seen it. I don't know that you've done this before in your other math classes, but we're being asked to solve for R. And R here is squared, so we do need to get rid of the square. So the first thing I want to do is, what's happening to this R squared, and it's being multiplied by pi. So I will divide out pi from both sides. And pi over pi cancel. So what do I have now? I have A over pi equals R squared. Okay, in order to eliminate the squared term from R, I need to take the square root. And let's do a little sidebar over here. If I have 5 squared, that equals 25, right? If I were to take the square root of 25, that would equal 5. Likewise, if I take the square root of anything squared, including R, that would isolate R. the square root of something squared equals whatever that is that's being squared. I'm going to highlight that in red there. So the square root of something squared equals that something. So I'm going to take the square root of this r squared. Now, if I do that to the right side of the equation, I also need to do it to the left side of the equation. So now I'm left with, I'm going to move my r to the left side. I've got my r isolated equals the square root of a over pi. One thing left to note. When we're dealing with square root, we want to always make sure to include both the plus and the minus in our answer. This is because in order to get to 25, we can multiply 5 times 5, for example, but we can also multiply negative 5 times negative 5 to get 25. Now, I'm not going to explore that a lot right now. That's not the topic of this lesson, but I did just want to show you enough of that just so that you could solve these equations. So here's our final answer. A equals, and the plus or minus is very important, plus or minus the square root of a divided by pi. And the last two on this page, we're solving for C. And what is happening to C? Well, S is being subtracted from C, so we'll simply add S. It's a capital S. We'll add it to the left side as well. And what that leaves us with is M minus S equals C. And I can rewrite that with my variable on the left, which I like to do. C equals not minus S, plus S. Sorry about that. C equals M plus S. So I added S to the right side. I add S to the left side. And M and S are not like terms, so we can't combine them. So that's always going to look like this. Okay, and here, number 8, we're asked to solve for M. Well, here's our M. What is happening to M? Something new. M is being divided by V. What is the opposite of dividing by V? Well, it's multiplying by V. So I'm going to multiply both sides by V. And that does isolate my M. So I'll have on one side of the equation, I have M. And on the left side of the equation, I have V times D. I like to put them in alphabetical order. D, V, and then I'll rewrite it with variable that I solved for on the left, M equals dV. Okay, let's do a few more of these. So as we think about these, I don't like PEMDAS, but think backwards order of operations. Okay, we will do generally addition and subtraction will usually be done before multiplication and division. To remove a fraction, we multiply by the reciprocal, the inverse. So the inverse of 1/2 is 2 over 1. The inverse of M over D would be D over M. These are not equal, they're inverses or reciprocals here. So the last step usually, so we talked about this. Our last step is usually, but not always, to divide by whatever is next to your variable. Next to means whatever is being multiplied by your variable. So why don't you try 9, 10, 11, and 12 on your own, pause the video, and then come back and check your work. Okay, I hope you tried these on your own. We're solving in number 9 for h. So let's think about what's happening to h. So we've got a on the left. On the right, h is being multiplied by 1/2 bh. Let's deal with this fraction first. So let's multiply both sides of the equation by 2. And now I have 2a equals, now this becomes an invisible 1. The 1 becomes invisible. 2a equals bh. Remember, we're solving for h. So what is happening to h? It's being multiplied by b. So I will divide out b. And I have my h isolated. Now, all of this cannot be simplified, this left side of the equation. So I just rewrite it. That's my answer. H equals 2a divided by b. Very similar is this problem number 10, but in this case, we're solving for that uppercase b. So we need to solve for uppercase b. But before we divide out the h, I want to deal with this 3, and I'm going to do that by multiplying by 3. Remember, this 3 is division. A fraction is division. So the opposite of division is multiplication. So we'll multiply by 3, both sides of the equation. So, and the 1 now becomes invisible. So now I have 3v equals uppercase b, lowercase h. Again, what is happening to h? H is being multiplied by b, so I will divide by b. Oops, what is happening to b? We're solving for b. Always remember that. It's being multiplied by h, so I'll divide by h. And b equals 3v over h. And that is a final answer. Now we're solving for m. Let's highlight this m. This is what we're solving for, m. I think the first thing we want to do is let's deal with that denominator. This mv squared is being divided by 2. So let's multiply both sides of this equation by 2. And that will simplify it quite a bit for us. So now we have on the left side 2k equals mv squared. Remember, we're solving only for m. We're not solving for v. So we will not need to take the square root of the term in this problem. So we're solving for m. What's happening to m? M is being multiplied by v squared. So I can just divide by v squared. Whatever I do to one side of the equation, I do to the other. And we cancel this. And then m equals 2k divided by v squared. See, we didn't even need to take the square root. That wasn't so hard. You know, I guess to some extent, student, you can think of these, what if they weren't letters? What if this were a triangle? Okay? That would be okay. We could solve for triangle. Maybe we'll do that after we solve for b. What are letters? They're just graphical representations. So we're solving for b, and the first thing we want to do is take care of this fraction. So we're going to multiply both sides of this equation by d. cross out that. I don't want to use the yellow, it doesn't show up very well. So on the left side of the equation, I have dA. I'm just going to use the commutative property to write it AD because I like my variables in alphabetical order. dA equals AD, we know that. B plus C on the right. Now remember, we're solving for B. What's happening to B? C is being added to it, so we'll subtract C. And whatever I do to one side of an equation, I have to do to the other. So on the right side, I have my B isolated, but on the left side, I have AD minus C. Now, I know I told you that I like to put my variables in ABC order, if possible. Here I cannot. AD is a term, and from AD, C is being subtracted. So I can't change the order of those variables for those purposes. Our final answer is B equals AD minus C. I put the B on the left because that's what I solved for. Let's move on. Let's do 13, 14, 15, and 16. Try them on your own and then come back. Pause the video and try those on your own, please. Okay, I hope you tried those on your own. In here, in number 13, we're solving for W. P equals 2L plus 2W. So W is locked in this term with a 2W. So what I want to do is leave this alone for a minute and let's get rid of the 2L. Now remember, here we have an invisible positive sign. So we can say 2L is being added to 2W. So the opposite or inverse operation would be to subtract 2L, excuse me. Whatever I do to one side of the equation, I do to the other. So on the left side of the equation, I have P minus 2L. Being careful to keep my uppercase, and lowercase where I have them as lowercase. And on the right side, I have 2W. Now remember, we're solving for W. What is happening to W? W is being multiplied by 2. So I will divide by 2. Whatever I do to one side of the equation, I do to the other. And now I've isolated my W, and W equals all of this. P minus 2L, that quantity, divided by 2. In number 14, we're asked to solve for Y. These are multi-step equations. Y is locked in this term with B, so let's leave that alone for now. Let's isolate BY first. We have a positive AX here. So AX is being added to BY. So let's subtract that AX. Whatever we do to one side, we do to the other, which leaves us with BY equals C minus AX. So again, what is happening to Y? Y is being multiplied by B. So we will divide by B in order to isolate this Y, which leaves us with Y equals C minus AX. All of that divided by B. And that's the final answer. Number 15, we're solving for X. X is locked inside this mx term, and this is the slope formula. You'll learn that pretty soon in algebra, and we'll learn how that works and what that does. It's a beautiful thing. So for now, we need to isolate mx before we isolate the x. So we need to subtract b, and whatever we do to one side, we do to the other. So here on the left side, y minus b equals mx. Again, we're being asked to isolate, to solve for x. X is being multiplied by m, so I will divide by m, and x equals y minus b divided by m, another very useful formula. In number 16, we're being asked to solve for t. Here's t. It's locked into this PRT term here. So first, let's isolate PRT. So we've got a positive uppercase P here. So the first thing I want to do is subtract P so I can isolate PRT. I know that P appears twice on the right side. We'll deal with that in a minute. So on the left side, A minus P equals PRT. This is an interest formula. Now, what's happening to T? T is being multiplied by PR. The opposite or inverse reciprocal of multiplying by PR would be to divide by PR. And that cancels these. Now I've got my T isolated, and I'm done. T equals all of this. A minus P divided by PR. And that's the final answer. Last two problems, please try them on your own if you haven't yet. So we have C equals 5/9 times F minus 32. This is the formula for converting from Celsius to Fahrenheit. And they've asked us to solve for F. So I've got this fraction here. The first thing I want to do is I'm going to multiply both sides by the reciprocal of the fraction in order to pretty much eliminate that fraction. So the reciprocal of 5/9 is 9/5. Whatever I do to one side, I do to the other. So with that in mind, I can cancel this and this. And now I have 9/5 C on the left equals F minus 32. Okay, at this point, it's okay for me to omit those parentheses. So now let's remind ourselves, we're solving for F. What is happening to F? F has 32. 32 is being subtracted from F. The opposite of subtracting 32 is adding 32, which we will do to both sides. So on the right side, we have F isolated. On the left side, 9/5 is locked in as part of this term, C. So we're not going to take 32 and add it specifically to 9/5. We're adding it to the whole term, which is actually rather easy. So we just write 9/5 C plus 32. And that's our final answer. So let's rewrite it with the variable on the left. Fahrenheit equals 9/5 Celsius plus 32. That's converting Fahrenheit to Celsius. You can impress your science teacher with that. Now, I know number 18 looks a little bit difficult, but let me tell you a couple of things that are going on here. Remember I said these letters, I mean, they could actually be triangles or they could be squares. Okay, it's just symbols that we're manipulating. And that's how I want you to think of this B1 and B2. We're not going to combine them. They're not like terms. We're not going to add them together. It's just something called B1. Okay, later in algebra, we'll look at different formulas and things that have a B1 or B2 or something else similar to that. But for now, they're just symbols to you. So we have, we want to solve for B1. And we have on the left side of the equation A, on the right side of the equation, 1/2 H times the quantity of B1 plus B2. Well, I think the first thing we want to do is deal with this fraction. So we're going to multiply by the reciprocal. Well, the reciprocal of 1/2 is 2/1, which, because we have 1 in the numerator, we're really just multiplying by 2. So that's what we're going to do. We're going to multiply both sides by 2. So these go away. On the left side of the equation, I have 2a equals, and then I have h times the quantity of b1 plus b2. Let me get a darker color here. Okay, we're isolating for b1. Here's my b1. B1 is, remember, think of it as gems backwards, okay? We're going to deal with the grouping symbols last. So I'm going to keep everything in the grouping symbol, but all of this in the grouping symbol is being multiplied by h. So let's just divide everything by h. And whatever we do to one side of the equation, we have to do to the other side of the equation. So now we've taken care of h. And we have 2a divided by h on the left, and on the right we have b1 plus b2. We're solving for b1. All we really need to do is subtract b2 at this point. So whatever I do to one side of the equation, I'll do to the other. And I'm going to have to write over here and make a sidebar. We're left with b1, which we isolated, equals 2a divided by h minus b2. And that is a final answer. So let's go back to our exit ticket. We had a couple of questions. The first thing that you should ask is, what variable am I solving for? And why is it that literal equations do not simplify nicely? They do not simplify nicely because you are not able to combine like terms due to multiple variables. So that's our lesson on literal equations. I know with a lot of practice, you will learn to love, love, love literal equations. They can be a fun puzzle to solve. And I think that if you work hard and practice, you'll be really great at it. And you'll be a superstar at algebra. You've got this.